Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about the addition and subtraction of matrices. Before we begin, if you are new to MyScience Tutorials, make sure you consider subscribing and pressing that notification button so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So for us to be able to add a matrix, we need to make sure the order of the matrices are the same. So what do I mean by this? So what I mean by this is what we can add or subtract a 2 by 2 matrix. Okay, we can add or subtract a 2 by 2 matrix to another 2 by 2 matrix. It is allowed. We can add a 3 by 3 matrix, okay, or subtract it from another 3 by 3 matrix. The same way we can add, let's say, a 2 by 3 matrix, okay, or subtract it from another 2 by 3 matrix. Okay, once the order of the matrix is the same, we can add or subtract them. But in the cases where the order of the matrices are not the same, for instance, we have a 2 by 2 matrix, okay, we have to add or subtract it from another matrix of the order 2 by 3. This is not possible. We cannot add or subtract a matrix that do not have the same order. So let me use red to depict that. So it means this matrix, we cannot add this matrix because they do not have the same order. The same way we cannot add a 2 by 4 matrix. We cannot add or subtract a 2 by 4 matrix to, let's say, a 3 by 3 matrix, or let's say a 4 by 4 matrix. We cannot add or subtract a 4 by 4 matrix to a 4 by 3 matrix. This cannot happen. So we can only add matrices that are of the same order. So let's look at how to add matrices. Okay, so how to add matrices. So assuming we have matrix A given to us by, let's say, A, B, C, and D, and another matrix B which is given to us by E, F, G, H. Okay, if we are asked to find let's say A plus B, all we need to do is to add, let's say, this is how we add the matrix. So we add the A, the first element over here with the first element in the second matrix. Okay, so we add A plus E, so we add this with this, then we add B with F, so this becomes B plus F. The same way we add C with G, so we have C plus G, then we add D with H, so we have D plus H. So we can see that if the matrices do not have the same order, okay, you may not be able to add some of the elements because the matrices, the orders are different. For instance, if we have, let's say, a 2 by 4 matrix that is 2 rows, so we have let's say 2, 4, 6, 8, 1, -2, 3, and 4. Okay, so let's say this is B, so this has 2 rows and then 4 columns, so this is 2 by 4 matrix. And we have matrix C, which is let me say 3 by 4 matrix, so 3 by 4, so I have 1, 2, 3, 4, 5, 6, 7, 8, -1, 2, -4, 7. Okay, so here I have 3 rows, so it becomes 3, and then columns, I have 4 columns, this becomes 3 by 4. Now the fact that the order of these two matrices are the same means we cannot add them. So if we are supposed to add B to C, this is what we are supposed to get. So we can add, let me use another color, so we can add the 2 over here to the 1 over here, then we add the 4 over here to the 2 over here, then we add 6 over here to this, then we add the 8 over here to the 1 over here. Now you get to realize when we are adding the rows, we can add them and we have their answers over here respectively, over here. But what happens if we are now adding the second row? If we add the second row, we are also going to get the answer over here, but this guy does not have a third row, and then this guy has a third row. So in that case, this guy only has 2 rows, and then this guy has 3 rows. So you can see that one row is missing, so we cannot add that. So the fact that we cannot add the last row because this one has a last row and this one does not have the third row means what? Our answer over here is going to be what? Invalid. Okay, we can add all the other elements and leave this row unadded. Okay, so that is why we can add matrices that do not have the same order. So for us to be able to add matrices, we need to make sure they are of the same order. Like for instance, this case, this is a 2 by 2 matrix, so we can add it to another what? 2 by 2 matrix. All right, so the other thing we need to note is that addition of matrices is commutative. So addition of matrix is commutative. What it means is that if we have matrix A and we add it to B, it is equal to if you have matrix B and we add it to matrix A. It's the same thing. Or if we have matrix A plus B, we add them first before we add another matrix C. It is the same as what? If we add matrix A, if we add matrix B to C before we add matrix A, provided all the matrices over here have the same order. Okay, so we need to make sure they have the same order before we can add them. All right, so with this basic introduction to addition of what? Matrices, let's have a look at an example. So example number 1, if you have the matrix M is equal to, then we have 10, 8, 1, 2, 4, 5, 7, 3, and 2 as our first matrix, and then the second matrix is what? 2, 4, 2, 1, 7, 2, and then 3, 3, 4. And we have to find I, M plus N, I, N plus M, and I. We have to show whether addition, okay, is commutative. All right, so let's write down the solution for this example. Now, first of all, we need to check whether the order of the matrices are the same before we can be able to add them. So we have, this is row 1, row 2, and then row 3. So we have 3 rows multiplied by, we have column 1, column 2, column 3. So this is a 3 by 3 matrix. This matrix is also, it also has what? Row 1, row 2, row 3, and then column 1, column 2, column 3. So this is also what? A 3 by 3 matrix. The fact that the order of the matrices are the same means we can easily add them. So let's look at I. So M plus N is simply the addition of the two matrices that we have. So we have 10, 2, 7, 8, 4, 3, then 1, 5, 2, plus the second matrix, which is what? 2, 4, 2, 1, 7, 2, and then 3, 3, 4. So let me use another color to show the final result. So first of all, we add the 10 over here to the 2 over here. So 10 plus 2, that is going to give us 12. Then we add the 2 over here with the 4 over here. So 2 plus 4, that is going to give us what? 6. Then we add the 7 over here to the 2 over here. So 7 plus 2, that is going to give us 9. Now 8 plus the 1 over here, that is going to give us 9. Then the 4 over here plus the 7 over here. So 4 plus 7, that is going to give us 11. Now 3, okay, plus the 2 over here is going to give us 5. So if we come to the last row, we have 1 over here, then we have 3 over here. So 1 plus 3, that is giving us 4. We have 5 over here, we have 3 over here. So 5 plus 3, that is going to give us 8. then we have 2, and then 4 over here. That is going to give us 6. So if we add matrix m to n, we are going to get this as our final answer. So we have 12, 6, 9, 9, 11, 5, then 4, 8, 6. Now let's look at the second one, that is if we are adding matrix n first to m. So what we are going to get, so we have matrix n is what, 2, 4, 2, 1, 7, 2, and then 3, 3, 4. So we are adding that to the second matrix, which is what, 10, 2, 7, 8, 4, 3, then 1, 5, and 2. So let's have a look at our solution. Okay, so let me use white as the answer for this. So first of all, we need to add the first row to the first row over here. So we add the 2 over here, okay, to the 10 over here. So 2 plus 10, that is 12. Then we add the 4 over here to the 2 over here. So 4 plus 2, that is going to give us 6. And then we add the 2 over here to the 7 over here. So 2 plus 7, that is going to give us 9. So if we add the 1 over here to the 8 over here, we are going to get 9. Then we have 7 plus 4, that is going to give us 11. Then we have what? 2, and then we have 3. So 2 plus 3, that is going to give us 5. If we add 3 and 1, we are going to get 4. If we add 3 and 5, we are going to get 8. And if we add 4 and 2, we are going to get what? 6. So this is n plus m, and then this is what? M plus n. Now if we compare the two matrices, we can see that they have the same elements. Okay, so the fact that the elements, or because matrix m plus n and n plus m has the same elements and are equal, we can see that what? Matrix m plus n, okay, is equal to what? Matrix what? N plus m, because they have the same elements and then they are also equal. So therefore addition, so the I aspect, therefore addition of matrices, so addition of matrices is what? Commutative. Right, so now let's look at how to subtract matrices. So if you want to subtract matrices, let's say we have matrix A, which is equal to A, B, negative C, and D. And we have matrix B, which is equal to negative E, negative F, then G, and then negative H. So we are to find, let's find 1. We have matrix A minus B, and then II, matrix B minus A. Okay, and we are also to see whether they are what? Commutative or not, or we have to identify whether subtraction is commutative or not. So let's look at how to subtract matrices. So if we are going to subtract matrices, okay, so let's say let's subtract the first one. So we have A minus B. So it means we write our first matrix, which is A, B, negative C, and then D, then minus the second matrix, which is what? Negative E, negative F, G, and then negative H. Okay, so if we subtract this, we are going to subtract A. So we have A, so we have A here, then this negative sign minus, then into bracket the negative E we have over here, negative E. Okay, then we go to the second side, we have B, negative F, so we have B minus this minus, then minus F over here, then we have negative C, okay, minus G, and then we have over here D, okay, minus, then minus what? H over here. Okay, but mind you, this is a 2 by 2 matrix, and then this is also a 2 by 2 matrix, so we can subtract them because they have the same order. So if we simplify this, we are going to have what? A plus E at the top over here, then B plus F at the top over here, then negative c minus g, and then what, d plus what, h over here as the solution for what, matrix A minus B. Now let's find matrix B minus A. So B minus A, we have, let me use another color. Okay, so B minus A, we have negative E, negative F, G, negative H, then minus matrix A, which is what, AB, negative C, and then D. So this is equal to, then we have the B coming first, so we have negative E minus A, then we have negative F, okay, minus B, so negative F minus B, then we have G, okay, minus G minus negative C, so negative C over here, and then we have negative H minus what, the D we have over here. So if we simplify this, we can see that we have what, negative E minus A, negative F minus B, then we have what, G plus what, C, then we have what, negative H minus D. Now if we compare this and this, we get to realize that over here we have A plus E, but here we have negative E minus what, A, and they are not the same. Okay, so this is also different from this is also different from this, and this is also different from this. So from just this, we can conclude that what, subtraction of matrices of the same order is not commutative. So let's have a look at a practical example. So we have matrix A is equal to 5, 3, 2. Then we have 8, 4, 1. Then we have matrix D is equal to 1, 2, 0, then 3, 0, 1. So we have to find I, A minus D, I, D minus A, and then I, whether subtraction, okay, is commutative. So we have to find whether subtraction is commutative. So let's write down our solution. Okay, so first things first, I need to determine the order of the matrices and see whether I can be able to what, to add them. So I know this is my first row, this is my second row, this is my first column, column 1, this is my second column, this is my third column, from top to down, top to down, top to down. So it means I have 2 rows and 3 columns, so it's a 2 by 3 matrix over here. So this side also has the same one. I have row 1, row 2, that is from here, okay. Then from top to down, I have what, column 1, column 2, and then column 3. So this is also a 2 by 3 matrix. So the fact that both of them are 2 by 3 matrices, I can add or subtract them easily. So let's look at I. So matrix A minus D is equal to, I write down the matrix A, so which is 5, 3, 2, 8, 4, 1. Then minus matrix D. Matrix D is what, 1, 2, 0, then 3, 0, 1. So this is equal to, then I write a bigger bracket over here. So let me put them into brackets. So I have 5 minus 1. So I'm going to write 5 minus 1. So this minus this. Then the second one is going to be 3 minus 2. So I have 3 minus 2. Then the third one is going to be this 2 over here minus 0. So I have 2 minus 0. So I come down. I have 8 here and 3 here. So it's going to be 8 minus 3. Then 4 minus 0. So I have 4 minus 0. And then the last one, 1 minus 1. So it's going to be 1 minus 1. Sorry, 1 minus 1. So finally, my matrix is going to be 5 minus 1. That is going to give me 4. Okay. 3 minus 2 is going to give me 1. 2 minus 0 is going to give me what? 2. And then 8 minus 3, that is going to give me 5. 4 minus 0 is going to give me 4. And then 1 minus 1 is going to give me 0. So this is what matrix what A minus what D. So let's find matrix what D minus A. So for D minus A, let me use another color. So for D minus A, I have matrix D first. So I have 1 2 0 and then 3 0 1. Then minus matrix A, which is what 5 3 2 8 4 1. So that means I have something like this. So I have matrix D first, that is 1, then minus the 5 over here, so 1 minus 5. Then I have the 2 minus 3, so I have 2 minus 3. Then I have 0 minus 2, so I have 0 minus 2. So if I come down here, I have 3 minus 8, so 3 minus 8. Then I have 0 minus 4, 0 minus 4 over here. Then over here 1 minus 1, so I have 1 minus 1 over here. So my final answer is going to be 1 minus 5 will give me negative 4, 2 minus 3 will give me negative 1, 0 minus 2 will give me negative 2. So 3 minus 8 will give me negative 5, 0 minus 4 will give me negative 4, and then 1 minus 1 will give me 0. So I can see that matrix D minus A, okay, is not equal to matrix A minus D, because over here the values are all positive and then over here the values are all negative. So because what A minus D is not equal to what D minus A, it implies that what subtraction of matrices, subtraction is not what is not commutative. Okay, so thank you so much for watching. This is the end of how to add and subtract matrices. So I hope you've learned something new, and I will see you in the next video. Bye bye.